Hey guys, welcome back to my series on restoring classic late 40s American black and white electrostatic televisions. In this series I'm going to be pointing out some of the differences between these sets and the more common magnetically deflected sets, give you some tips, some tricks, some suggestions, some pitfalls to avoid to get these up and running. Alright, when we last left off, we got a nice stable raster, meaning the electron beam is painting a nice rectangle on the screen and we can move it around. Everything looks good. Now we want to try feeding a signal in. If you haven't noticed already, yeah, the horizontal oscillator kicks in before the vertical. Let's manipulate the controls a little bit. Alrighty, so we got a nice green, even glow across the screen. Let's try feeding a signal in. This set, like most sets of that era, have a twin lead screw connector on the back. It's 300 ohm twin lead. It goes right down into the tuner. Most more modern signal sources are 75 ohm coax. So this little guy converts 75 ohm unbalanced to 300 ohm balanced. That's where the bal-un name comes in. Bal-unbalanced to our balance unbalance converter. And I'm going to feed in a test signal. Now I have a nice test pattern generator. If you didn't, any 75 ohm impedance RF modulated source, like an over-the-air converter box, an old VCR, an older DVD player that has RF out, or get yourself an RF modulator. They're plentiful. Something that will put out NTSC modulated video on channels, say 3 or 4s, most typical. Alright, so I've got that hooked up. I've put all the tubes back in. Remember, I checked them early on. They were all good. They all appear, most of them appear to be the original Admiral, so I guess we got lucky there. Let's turn on the test pattern generator. It's on VG91. Set to channel 4. Got, let's see, it's the crosshatch pattern, and I've got it on maximum output. I can already tell there's some indication of something going on the screen, so that's good. I don't have the channel number plate in front of me, so I'm just going to rotate this around. Now, there's all sorts of problems that could crop up, from the tuner being dirty to the IF alignment being off to, of course, we haven't recapped the whole thing yet, but let's see if we can get something. The fact that there's snow is always a good sign, because that means it's picking up random noise via the tuner, and it's getting down converted, and it's modulating the FM with noise. If, say, the video amp was dead, the detector was dead, there would just be an even color on the screen. You wouldn't have that snow. And it's changing when I change channels, which means the local oscillator is working. It's doing something when I change channels. Those are all very good signs. And hey, that's a hint of a crosshatch. Just knowing how these Admirals usually go, or most TVs, that kind of channel 1 was like ups, and well, there is no channel 1, but what I'm trying to say is, like, this is probably channel 2, 3, 4. Fine tuning. Yeah, that makes some difference. Contrast. Excellent. If you go down, it fades out. You go up, it comes in. Alright, time to start playing around with the controls on the back. So we have a horizontal hold and vertical hold. Ha 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 ha. Close, close. Fight with these controls. Ooh, ooh, ooh. That's the horizontal hold. So I was on the wrong channel. So channel 4 is at the 3 o'clock position, completely horizontal on the channel selector. I was trying to tune on channel 3. There we go, 4. Excellent. Now we can really see that vertical linearity is terrible. And the vertical linearity control is barely doing anything. So we're definitely going to be going after that next. So width, excellent, because of course that should be a circle, not egg-shaped. There's vertical hold. It actually locks pretty solidly. So I figured out what was going on. So yeah, a little egg-shaped, a little bottom heavy. Cool. Just in fine-tuning. It's a little fuzzy. I am feeding in a strong signal, and it's not the greatest reception. So now here's the crosshatch I was doing earlier. Horizontal linearity looks pretty good, meaning that the crosshatch pattern, every square should be exactly the same height and width. And, you know, again, they're squished at the bottom, stretched at the top. And we have a lot of interference. Now part of that is, remember, there was a shield on the original picture tube that came with this. This scope CRT does not have a shield. So we're not going to get too concerned about noise and snow and interference right now. We won't worry about that till we get the original picture tube back in with the shield in place. These high voltage generators put out a ton of noise. But how about that? We really get down to it. We haven't done all that much work yet. But I hope you can see why I put all that time and effort and discussion into the high voltage circuit. Because until you've got that squared away and you've got that stable, you have no hope of getting a good solid image. And by doing all that work first, now this is our oscilloscope. This is our indication of how good a signal's coming through. So as we go through this should get sharper and cleaner and nicer looking, and of course improve that linearity. So let's look at the vertical linearity circuit next. Also want to point out, very few electrostatic TVs have a vertical linearity control. Every magnetically deflected set has a height and a linearity. Most electrostatic do not. Likewise, there's no horizontal linearity control on this set, and most do not. Sometimes there's a trimmer cap. That's about it. Why? Because they're relying on these oscillators to produce a super clean linear sawtooth wave, which should eliminate the need for a linearity control. And early revisions of this chassis didn't have it, but this one does. They hacked it in here. It's picked off. They pick off part of the output through some high value resistors, a 10 meg resistor, 2.7 meg, and then a 5 meg pot, coupled through a 10 meg and a 4.7 meg. So these are super high resistance values all down through here. And then through, it says 001. I think they lost, well, I'm not sure. I'd say they lost a decimal point. However, if you look around, there's a 0.01, there's a 0.01, there's no leading zero. So we got to take a look at C58 and figure out what is that supposed to be. So it's supposed to be 0.01 or what's going on there. Anyway, that goes up to pin 1, right where those two caps are replaced. So it looks like they're picking off some of the output and feeding it back into the input to affect a linearity control. More commonly, well, at least the magnetically deflected sets, they would vary, say, this 3.3K resistor to do linearity. But they figured out a way. Like I said, most electrostatic sets do not have this. They figured out a way using these resistors and a capacitor to well, allegedly make it happen. Of course, in our case, it's not working. So we're going to check out all these resistors are suspect. We got to make sure this control is good. I can't remember. I don't think I know I cleaned all the high voltage pots. I'm not sure I cleaned that one. So we got to check that, and then check down that capacitor and see what is going on with that. What kind of value it is, what material is it made out of, where is it located. So that is a linearity control. It's 10 meg and a 2.7 meg. Looks like they grounded this end of it. There's 4.7 meg. There's that cap. Right, that was after the 4.7. And that is a 0.001. So The dot was missing from that. It just said 001 on the schematic. It's a .001. So, of course, paper caps, they get leaky, they deteriorate. That's my number one suspect. But we also want to check these resistors. Alright, I just replaced that cap. I checked all the resistors. They seem to be in the ballpark of the correct value. Let's see what difference replacing that cap makes. Huh, interesting. I didn't touch any of the controls, and we had a stable lock earlier. Well, that's good. Circuits generally interact a bit with each other, so. Alright, turn the brightness down. It didn't do it. It's a little bit of an effect. When I get towards this end, it'll squeeze a little bit and stretch a little bit, but otherwise, no. Alright, so a few other thoughts. One, I'm going to swap out this 6SL7 tube. That's the easiest thing to try, so let's do that right now. I just happen to have a spare nearby. I just happen to have another one handy from a Motorola chassis I'm working on at the same time. So very easy to replace. Alright. If it's not that, I verified that there's 5 meg across that pop, but I didn't verify that the wiper varies as I go through it. There's a 10 meg resistor that was measuring like 8.5, but I wouldn't think that would make the control not work at all. Nope. Alright, not the tube. Not the tube. Alright. Well, that's annoying. It seems unlikely because these, well, never say never, right? I mean, when you eliminate every other possibility, which we haven't yet, but there is one cap in here, I believe it's 100 picofarad. That's part of, I think it's the phase inverter. It's that guy. So it's in a critical part of the circuit. All the stuff has to be good. That's how you get your phase inversion. Because the problem with this is one half of the tube is working harder than the other half. We can also look at it on a scope. Now, I recently demoed this cheapo scope. I did order up an X100 probe for it. It'll be here tomorrow, which will divide the incoming signal by 100, which will let this handle the higher voltages you see in tube circuits without any cause for concern. It should be able to handle it with the probe, the times 10 probe that came with it. I think it can do up to 400 or 500 volts. I just don't feel as confident, so I'll wait till that probe comes in. But meanwhile, I do have my Tektronix scope we can use. I'm trying to think of what other possibilities. Huh. Well, that's curious. So while I've been babbling, I left the set running, and the linearity's gotten better. So, of course, there is another possibility staring us in the face, which is I haven't recapped most of the set. It's mostly running on the old leaky paper caps and replacement electrolytics. And it's definitely looking a lot better now. And if I reduce that height a bit, it's probably going to be a darn near perfect circle, in spite of all the noise we have. So, I guess it maybe sort of fixed itself. But does the control do anything now? It does. That's what the control is supposed to do. Well, you know, I was about to say, never too old to learn something new, but I've seen this before. It's an old set. It hasn't been turned on in decades, and we haven't done all that much work to it. It's got to take some time to wake up and those old electrolytics to form up and crud to burn off and whatever. But number one suspect, as usual, is paper caps. Now, I did recap the vertical output amp. I did not recap or do anything to the vertical oscillator that feeds it. All that being said, that was weird. And I'm glad I left this set running while I was babbling, because if I hadn't, I would have launched into troubleshooting mode while the set just fixed itself by by me running it a little bit longer. Well, that's cool. And that is one nice thing about these electrostatic sets, is they tend to have excellent linearity. Much easier to create a linear sawtooth waveform than it is to have linear current going through an inductive yoke with screen geometry and all that. Just a little hard to tell with the interference here, but yeah, I mean, generally all those squares are the same size, so that's really cool. Excellent. So where do you go from here? Well, if you've made it this far and your set is working this well, I'd say take your pick. Eventually we do want to replace all these paper caps. I do want to rebuild the power supply, replace those old electrolytics. Even though it seems to be working okay, I'll leave that up to you. This is, in my particular case, this is for a customer who lives rather far away. It's not easy for him to bring it back to me if there's an issue. So I'm just going to be replacing the few electrolytics up here. But as far as where I want to go from here, I want to get the image looking a little bit better. So we've got a video amp down here. It's very simple. We go from a 6AL5 detector right to a 6AU6 video amp, and that drives the cathode. Just a one-stage video amp. And then there's also the AGC, which I believe is this big 0.25 microfarad cap up here. What it does is, it's just like in an AM radio, it looks at the detected signal strength and uses that for a feedback signal to the front end to control the gain. Here it is the next day, and a new toy has arrived. It is a P4100 100 megahertz 100 times high voltage oscilloscope probe. This will divide the incoming voltage by 100. What that means for us is, even with a little handheld scope like this, we can probe around in a TV without being concerned about burning it out. Now, with the times 10 probe that came with this scope, they say it's good to, I think, 400 volts or something like that, which should be enough margin, but I like going with this, which is rated for 2000 volts. We just have to remember to multiply what we see on here by 10, because this only has times 1 and times 10 settings in it, so you have to do the math and multiply the displayed voltage by 10. But let's see what we can see in this set. Also want to see, now that this is completely cooled down, is that vertical linearity problem going to creep back in? And we can also look at that sawtooth waveform on this, I hope, and see what it looks like on a little scope screen. So let's get this hooked up. So I've grounded it to the chassis, and I've clipped my probe right to one of the plates of the 6SL7, and there we go. There is our sawtooth. Cool. So yeah, absolutely, it does work just fine. It's having a little bit of trouble locking. There is a setting in the menu for triggering on the rising or falling edge. If I reverse that, it may work out all right, but let's see what we got. So it says volts peak to peak 30. It's actually 300. Now what I want to see is, if I turn the linearity control, what's it going to do to that display? So let's rotate it. So here it is the one way. Hey, look at that. It's curving down. It's bowing down. on that rising edge. And if I go the other way, it starts leveling out. Looks pretty good there. And if I keep going, now it's going like this. So we went from this to straight to the other way. And if I put it on the opposite plate, we should see a 180 degree out of phase. And there we go. So it's going the other way. And if I turn the linearity on this, this gets distorted as well. Let's see about those triggering modes and see if we can change this. So if we long press this, we can do rising or falling edge. So let's flip that around. Oops. I'm not the most adept with using this interface. How do I get it out of the menu? Always that way. This can change modes. Alright, so by changing the trigger mode, now we can see this opposite waveform. And if I adjust linearity, see it on this one as well. I think this is a good point to break off. When we resume, we're going to see what effect, if any, replacing a cap on the EGC and video amp had, and I'm going to talk about some other alternatives to use in place of a 7JP4. I've been using a 7VP1, which are pretty darn hard to come by, but there are other cathode ray tubes you can substitute for a 7JP4. I just happen to have a couple of them. So, be looking forward to that next time. As always, thanks for watching.